Hello guys, welcome to my YouTube channel. In this tutorial, I will be sharing with you on how to simplify radical expressions. But before we continue, I want to encourage you to subscribe to this channel. Like the video, share the link with your friends, and also please remember to click on the notification button. Thank you very much for your support. Now, before we go into solving some of the problems, I want you to understand these basic rules. Number one is the product rule, and it states that the square root of the product of A and B is equal to the product of the square root of A and the square root of B. Number two rule is the quotient rule, and it states that the square root of the quotient of A and B is equal to the quotient of the square root of A and the square root of B. So these rules will be very useful as we progress. All right, now let's take some examples. Example 1, simplify the following radical expressions. To solve these problems, question A, we need to factor a perfect square from this value, 300. So if we do that, then this is going to give us 100 times 3. So now we can apply the product rule to this. So if we do that, we are going to have the product of two radical expressions, which are the product of the radical of 100 and the radical of 3. So this is going to give us the square root of 100 is 10, and the radical of 3 is not a perfect square, so just bring it here, and this is now the answer to this question. All right, let's look at question B. Let's also factor a perfect square from this first value, 162. So if we do that, this will become 81 times 2. And also, to factor a perfect square from a to the 5th power, we have to make the exponent an even exponent. So a to the 4th power times a, and multiply by b to the 4th power. B to the 4th power is a perfect square. So at this point, we can now apply the product rule to this, where we now have the product of two radical expressions, in which one of the radical will contain perfect squares. So we have 81 here times a to the 4th power times b to the 4th power, and the radical of 2 times a. So now the square root of 81 is 9. The square root of a to the 4th power is a squared. All right, so divide this 4 by 2, and that gives you 2. So a squared is the answer to that, and the square root of b to the 4th power is b squared. B squared. Divide the 4 by 2, and that gives you 2. Okay, so b squared. So now, since 2a is not a perfect square, all you need to do is just bring it here. So this is the answer to this question. I hope it makes some sense. All right, to solve this problem, we also need to bring out the perfect squares. So this will become 25 times 2 times x squared times y to an evil exponent, so that will be y squared times y times z. Alright, so now we can express this as a product of two radical expressions where we have all the perfect square in the first radical. So 25 times x squared times y squared, and radical of 2 times y times z. So this will be equal, square root of 25 is 5, square root of x squared is x, square root of y squared is y. So now we can bring the radical of 2yz closer, and this is the answer to this question. I hope this makes some sense. Okay, so let's also work on question D. To solve this problem, we have to factor a perfect square from 32. So this is going to give us 16 times 2, and also factor a perfect square from x to the 7th power. So you do that by just making the exponent an evil exponent, so make it 6 and times 1x. Okay, so times y to the 6th power. So this is an evil exponent already, so it's a perfect square. So now we can express this as a product of two radical expressions. So this will become 16 times x to the 6th power times y to the 6th power and radical of 2 times x. So the square root of 16 is 4. The square root of x to the 6th power is x cubed. So divide 6 by 2 and that gives you 3. That is why it becomes x cubed. And y to the 6th power, the square root of y to the 6th power is also y cubed. Divide the exponent by 2. Alright, so now we can multiply that by radical of 2x, and so this is the answer to this question. I hope this makes some sense. Example 2, simplify the following radical expressions. To solve this problem, question A, we are going to write this as a single radical expression, and so when we do that, we're going to have 12 radical of 12 times 3. So this will become radical of 36, and the square root of 36 is 6. So this is the answer to this question. Also, question B, we have to write this as a single radical expression. So this will become 50x times 2x, and this is now 100x squared. So the square root of 100 is 10, and the square root of x squared is x. So this is the answer to this question. I hope this makes some sense. Alright, question C. To solve this problem, we have to write this as a quotient of two radical expressions. So this will become radical of 5 over radical of 36. 36 is a perfect square, so this will be equal radical of 5 over 6. So this is the answer to this question. And also question D, to solve this problem we have to write it as a quotient of two radical expressions. So this will become radical of 2x squared over radical of 9 y to the 4th power. Now the square root of x squared is x, so we can write that as x and keeping the radical of 2 over there, and the radical of 9, square root of 9 is 3, and the square root of y to the 4th power is y squared. So this is also the answer to this question. I hope this is clear to you. All right, let's move on to the next one. Example 3, simplify the following radical expressions. So to solve question A, we are going to write it as a single radical expression. So this will become 234 x to 11th power y over 26 x to the 7th power y. So now this y can cancel out this from here, and 234 divided by 26, that's going to give us 9. So this will be equal the radical of 9, and x to the 11th power divided by x to the 7th power. All we have to do is to keep the base, which is x, and subtract 7, which is the exponent of the denominator, from the exponent of the numerator. The division rule of exponent. So we are going to apply that to this end. So this will become x to the 11th power minus 7. So automatically we're going to have 9x to the 4th power. So the square root of 9 is 3, and the square root of x to the 4th power is x squared. So this is the answer to this question. All right, question B. We also need to write this as a single radical expression, and this will become 9a to the 5th power b to the 14th power over 3a to the 4th power and b to the 5th power. So first we are going to 3 divided by 3 is 1, and 9 divided by 3 is 3. So this will be equal to a radical of 3. So a to the 5th power divided by a to the 4th power will become a to the 5th power minus 4, and also b to the 11th power minus 5. All right, so what we did is that we subtract the exponents of the denominator from that of the numerator, okay, for a, and also for b we subtract the exponent of the denominator from the exponent of the numerator, and that is why we have 3a to the 5th power minus 4 and b to the 14th power minus 5. So this is going to give us the radical of 3a, because 5 minus 4 is 1, so a, and b to the 14th power. 14 minus 5 is going to give us 9, so this is b to the 9th power. So now we can factor a perfect square from b. Okay, so if we do that, this will become 3a times b to the 8th power. So just make it an even exponent times b. So we can apply the product rule to this so that we can have the perfect square and a single radical. So this will be b to the 8th power times a radical of 3ab. So finally, this will be the square root of b to the 8th power will be b to the 4th power. Divide the 8 by 2 and that gives you 4. So b to the 4th power and radical of 3ab. So this is the answer to this question. I hope this makes some sense. All right, so this will be the end of today's tutorial. So if you find this video useful, please remember to like the video, subscribe to the channel, share the link with your friends, and if you have not yet clicked on the notification button, please kindly do that. Thank you very much for your support. I'll be looking forward to seeing you in our next video. Bye bye.